Alright, so your test tomorrow is going to be on 6.5, 6.6, 7.1, and 7.3. We're going to take the review one page at a time. So, any questions on anything from 6.5? Are there anything that you want me to go over? Let me know. Alright, if you think of something and want to come back to it, we can come back. What about 6.6? 33. Oops. Let's look at 33. So we want to combine these to just be one ln. So how can we get them, condense them together? Before we can cancel it out, we need it to just be one ln. Right now we have two of them. So we want to combine it to one. How can we do that? If we're adding, how do we condense it? Multiply. So we have ln of x times x plus 2 is equal to 3. Now we can cancel out that ln with an e. So we make our big base e. So these cancel. On the left, we have x times x plus 2. So we can distribute our x. So what would that give us on the left side? X squared plus 2x, and then that's equal to e to the third power. When you have an x squared and an e in your problem, usually we would factor this when we have x squared, so like what are two factors? Once we move it over, we would figure out what are our factors, but since we have e cubed, we can't do that with this one. So our answer would just be this. Or if you want to move the e over, it would be x squared plus 2x minus e cubed. So you won't have one like this on the test, but you do need to know that to cancel out that ln, you just make the big base e. Yes?
We don't need to simplify e to the third?
Not from, you can't do it from here unless you had a calculator.
Okay. On the test, if it was like that,
you won't have one like this, where you have an x squared and e to the third. You could have one that would be like 2x is equal to e to the third, then you could put this into the calculator. So if it wasn't x squared, you could put it in the calculator. Let's look at 17. Alright, so again, we're solving here. Multiply, so just like the one before. So we have log base 6 of 2x squared times 3 is equal to 2. What can we do next? Big base 6. So this cancels. What's 2x squared times 3? 6x squared. And then what is 6 squared? 36. How do we solve for x? Divide by 6 first. So then x squared is equal to 6. Then we take the square root of both sides. What's that one thing we can't forget when we square root both sides? Plus or minus. So x is equal to a positive square root 6 and a negative square root 6. Now we always have to check for extraneous solutions. So we would take our square root 6 and plug it into our x here. We only have one x to plug it into, so we're just going to plug it into that one. So this would be 2 times square root of 6 squared. Is this going to give us a positive number? Yeah, so that works. We're good there. Now we can take negative 6 and plug it in. So we have 2 times negative square root 6 squared. Is this going to give us a positive number? Yep, because we're just squaring the negative, so it's going to be positive. So they both work. So our answer is positive square root 6 and negative square root 6. How do we combine these to 1? Multiply. So ln, oh no, ln of x times x plus 4 is equal to 3. How can we get rid of that ln?
You put it like to e.
Make the big base e. So this cancels. How can we multiply x times x plus 4 on the left side?
X squared plus 4x.
Awesome. We distribute, so x squared plus 4x is equal to e cubed. So this is just like the one we did, number 33, just like 33. We can move the e over, but we can't solve it after that. We have x squared plus 4x minus e cubed, because we don't have two factors of negative e cubed that add to 4. So we would just leave it like this. So again, you're not going to have one like this on the test, but you do need to know that e and ln cancel. Let's look at number 6. Another good one. There was a question like this on the quiz that I would say was probably the most frequent incorrect answer. So this is a good one to do. We want to change these to have the same base. How can we do that?
Change of base formula.
Not the change of base formula. We're just changing the way that our base looks. So we want to make them the same. So we would change 16 to be 1 over 4 to the negative second. 1 over 4 to the negative second power. Because that negative would flip this to a positive 4, and then 4 squared would be 16. So this is the same value as 16. 1 over 4 to the negative second power is 16. They're the same value. So we're not changing anything in our equation. That was a common mistake. People would change this to be like 16 to the negative 2, or I don't know what they were doing. But they would change the value of this and like say it's 1 over 4 squared. That changes this value. That gives you 1 over 16, which is not 1 over 4. It's not equal. So you have to be careful. You don't want to change the value of it. So now what should we do? Yep, that would definitely work too. If you wanted to make 16 as 4 squared. My pencil just stopped working. Yeah, you can make 16 4 squared and the 1 over 4 to the power of negative 1, because that's not changing either of the values. You still have the same values for each, but you could do that also. You'll get the same answer too.
What happens to 3x?
What was your question?
What happens to 3x?
Well, that's my question to you. What do we do with it? Right, the 1 over 4 will cancel out, so this cancels out with this, but we still have this exponent here and this exponent here. What do we do with the two exponents? Multiply them. So this is negative 2 times 3x minus 2. So negative 2 times 3x is negative 6x, and negative 2 times negative 2?
Plus 4.
Positive 4. And what's that equal to? 5 minus x, so the exponent on the other side. So what can we do from here?
Combine like terms.
Combine like terms. So subtract, what did you say, Sydney? Subtract 4 on both sides. And we can add x to both sides. So we get negative 5x is equal to 1. So then what's x equal to? negative 1 over 5. Let's look at 15. Alright, so how do we combine them? Multiply, so this would be log base 3 of 3x times 2x plus 1 is equal to 2. So we just combined our two logs together by multiplying. What should we do next? We can distribute the 3x. So this would be log base 3 of 6x squared plus 3x is equal to 2. What else can we do? Get rid of the log by making our big base 3. So this cancels. So we have 6x squared plus 3x is equal to, what's 3 squared? 9. What should we do next? Subtract 9 on both sides. So 6x squared plus 3x minus 9 is equal to 0. Now we can factor. So a couple different things we can do to factor here. We started with a number that's not 1. So can we divide anything? Do we have anything in common that we can take out here? Divide everything by 3. So we can take out a 3. Divide by 3, divide by 3, divide by 3. So this would be 2x squared plus, I keep using my pencil hoping it would work, but then it just doesn't. Plus x minus 3 is equal to 0. We still have a number out front that's not 1, so what do we have to do now? Multiply the first and the last. So what's 2 times negative 3? Negative 6. What are two factors of negative 6 that add to 1? 3 and negative 2. So in our parentheses here, we have x plus 3 and x minus 2. What do we have to do when we start with a number that's not 1? Before we do that, we divide both of these numbers by that number. If it doesn't go in evenly, we put it in front of the x. So we can't divide 3 by 2, so we just move it out front. So this is 2x plus 3. If it does go in evenly, we simplify. So what's negative 2 divided by 2? Negative 1. And then we just want to set them both equal to 0. So 2x plus 3 is equal to 0. X minus 1 is equal to 0. So we solve for x. We get x is equal to negative 3 halves, and x is equal to positive 1. Are we done? We got to plug it back in. So we're plugging it back into our original. If we plug in negative 3 halves, do we get a positive number here? Nope, it's a negative, so it doesn't work. If we plug in 1, we get 1 times 3, which is 3, so it's a positive, we're good there. And then here we have 2 times 1 plus 1, so that would be 3. Again, positive number, so we're good here too. So our only answer is x is equal to 1. So this was a good factoring one. So we had to divide by 2 in this step here because we started with a number that's not 1. So anytime you start with a number that's not 1, you have to multiply the first and the last, and then you have to divide by that number out front. So that's just how we factor when we start with a number in front of that x squared. Any questions from 7.1? Number 2. So for these where we have to show if it's direct, inverse, or neither, we always have to set y equal to everything else in our equation. We want y all by itself. So how can we get y all by itself here? Divide by 5. So we have y is equal to 6x over 5. So y is all by itself. What do you think this is? So just a reminder, direct variation is when we have a number being multiplied to y, so this, or multiplied to x, so y is equal to a times x. Inverse variation is when we're dividing a constant by x, so y is equal to a over x. It's direct because, well, 6 over 5 is actually being multiplied to x. So our a here is 6 over 5. This is direct. This is a common mistake because people think, oh, it's a fraction, that makes it inverse. X has to be in the bottom of the fraction in order for it to be inverse variation. But since x is on the top, it's direct. So our constant here, that a, is 6 over 5. So I think it was the same thing for number 3, but our constant was 1 over 15, so that one's direct also. All right, let's do it. How can we get y all by itself? Multiply both sides by y. So we get 15y is equal to x. What do we do next? Divide by 15. So y is equal to x over 15. So same thing from the one before. X is on top, so it's not inverse variation. It's actually y is equal to 1 over 15 times x. So our constant here is 1 over 15. So that's what makes this direct variation. X has to be on the bottom for it to be inverse. Number 9. So it tells us that the x and y vary inversely. So what's our inverse variation equation? Y is equal to a over x. So we want to plug in our x and y and solve for a. So our y is 18 and our x is 5 over 2. So a over 5 over 2. So just like all the other ones, if this was a whole number for x, how would we get x out of the denominator? Multiply. So we want to multiply both sides by 5 over 2. So it cancels out on the right. Then we just have to multiply 5 over 2 times 18. A little shortcut way to do this is you have 5 times, if we break 18 down into 2 times 9 over 2, the 2's cancel. So this is actually just 5 times 9, so that would give us 45. So 45 is equal to a. Or you could do 5 times 18 divided by 2 in the calculator. You get the same thing. So now we plug this into our equation for a. So we have y is equal to 45 over x. And it tells us to plug in what for x? Negative 3. So y is equal to 45 divided by negative 3. So what's y equal to? Negative 16, 15, yeah, 15. So this is our equation, and this is our y. All right, let's look at 14. So 14, this one's 14, right? Or this 14? Okay. So we're multiplying, so we want to get stuff on the top to cancel out with things on the bottom. So if we have, let's look at our x's first. We have 5 x's on the top, 4 here and 1 here. And we have 2 on the bottom. So that means 2 of our x's on top are going to cancel out. So then how many x's on top are we left with? 3 x's. So if you wanted to, you can write this out. We have x to the 5th on top over x squared. Since we are dividing and the base is the same, you just subtract. Or you could write it out like this. We have x times x times x times x times x on top over 2 on the bottom. So then 2 of them cancel out. So different ways you could do this. I mean, just however you see it, you can do it that way. So that's our x's. Let's look at our y's. So if we have 1 y on top and 3 on the bottom, how many are we going to be left with? Where? Y squared on the bottom. Because we had 1 y on top and 3 on the bottom. 1, 2, 3. So then the y on top cancels out with 1 y on the bottom, and we're left with 2 on the bottom. And then we have 80 over 5. How can we simplify 80 over 5? What's 80 divided by 5?
60.
No. Oh, 16. I thought you said 60. Yep, 16. So that's our answer. Write it out this way to help you see. Doing it this way kind of eliminates any mistakes you could make. So, if it helps you, write it out the long way. Alright, so here we want to factor the top and then factor the bottom before we start. So, how can we factor the top? Do we have anything in common between these two terms?
10.
So we're looking for something we can divide out. So we can divide out an x.
Oh, no.
Because they both have an x in common. What are we left with when we take out an x? What would go inside our parentheses?
Oh, minus 5.
2x minus 5. Perfect. And then how can we factor the bottom? What are 2 factors of 12 that add to 7? Three and 4. So x plus 3, x plus 4. Do we have anything in common on the top and on the bottom? Nope. So we can't simplify anything here. So we're just left with x times 2x minus 5 over x plus 3 times x plus 4. So we're dividing here. So that means we keep the first fraction, change to multiplication, and flip the second. And just like before, we need a factor. So factoring the top left here, what are 2 factors of negative 3 that add to negative 2? Negative 3 and positive 1. So we have x minus 3 and x plus 1. What about the bottom left down here? What are 2 factors of negative 8 that add to positive 2? You said 2 and 4, right?
Yeah.
Positive 4 and negative 2. And then I'm going to factor the bottom, but write it up top here because I'm flipping them. So what are 2 factors of positive 8 that add to positive 6? Positive 4 and positive 2. So x plus 4 and x plus 2. And then I'm going to factor the top, but write it on the bottom here. So what are 2 factors of 3 that add to 4? positive 3, and positive 1. So now we want to see, do we have anything on the top that cancels out with anything on the bottom? X plus 1 and x plus 1. X plus 4 and x plus 4. Anything else? Nope. So what are we left with on the top? X minus 3 and x plus 2. On the bottom, x minus 2 and x plus 3. What did we cancel out? So we have to say x does not equal, x plus 1 does not equal 0, and x plus 4 does not equal 0. So what are the two numbers that x cannot equal? Negative 1 and negative 4. Awesome. So that's our answer. Alright, so we want to factor. What are two factors of negative 6 that add to negative 1? Negative 3 and positive 2. Perfect. What about the bottom here? What are two factors of 16 that add to positive 8? Positive 4 and positive 4. On the top right. So it's only two terms, so we're not factoring, but is there anything in common that we could take out here? A 3x. So they both are divisible by 3, and they both have x's in them. My iPad's just not writing at all. There we go. 3x. What are we left with when we take out a 3x? X plus 4. And then on the bottom, how do we factor this? Negative 3 and positive 1. So x minus 3, x plus 1. Alright, do we have anything on the top that cancels out with anything on the bottom? X plus 4 and x plus 4. X minus 3 and x minus 3. Is that it? Yep. So then what are we left with on the top? Three x times x plus 2. What are we left with on the bottom? X plus 4 times x plus 1. So we need to set x plus 4 does not equal 0 and x minus 3 does not equal 0. So what can x not equal? Negative 4 and positive 3. So if we just said x plus 1 times x plus 4, this would be like saying we distribute the 1 here, and then we're just adding x after. So you have to have the parentheses on both of them. So parentheses matter, the order does not. So get 14. Alright, so again we're dividing. So we keep the first fraction, change to multiplication, and then we flip the second fraction. Usually, since this is a whole number, it would be over 1, but we're flipping it, so now the 1 goes on top. And we do the same thing before. We want to factor. So what are two factors of 21 that add to negative 10? Negative 3 and negative 7? Is that what you said? Yeah. Yep. And then the bottom here is already factored. We only have x plus 2. Can't do anything there. Top on the right is just 1, so we don't need to factor that. Bottom right. What are two factors of 49 that add to negative 14? Negative 7 and negative 7. So anything cancel out. X minus 7s. So what are we left with on the top? X minus 3. And what are we left with on the bottom? X plus 2 times x minus 7. What is our domain? What did we cancel? Awesome. It's positive 7. We cancel out the x minus 7, so we set this not equal to 0. Add 7. So x cannot equal positive 7. So let's look at 6.
Have a good day.
You too. So 6, we have 4 terms. So we're going to have to factor by grouping on the top. So we group the first 2, group the second 2. What do we have in common in our first 2 terms? 6x squared. So we take out a 6x squared. What are we left with? So we divide both of these by 6x squared. X minus 1. And then what can we group out of the second 2? What can we take out here? 5. And then what are we left with when we take out a 5? X minus 1. So then when we factor by grouping, we put the first 2 numbers together. So our first parentheses would be 6x squared plus 5. And our second parentheses is x minus 1. So whatever is in common. And then let's factor the bottom. So the bottom is the difference of 2 perfect squares. Not yet, actually, because 72 is not a perfect square, neither is 50. So what can we take out of these 2 terms? Do they have a number in common we can take out? Are they both even numbers? Yeah, so we can divide out a 2. So we take out a 2, and we're left with 36x to the 4th power minus 25. Now we have 2 perfect squares. So whenever we factor 2 perfect squares, we have the square root of the first. So what's the square root of 36x to the 4th power? 6x squared and 6x squared. Then one of them's plus, the other one's minus, and then what's the square root of 25? 5. So here we have 2 times 6x squared plus 5 times 6x squared minus 5. Anything in common on the top and on the bottom? 6x squared plus 5. So these cancel. And then, what are we left with on the top? X minus 1. And on the bottom, we have 2 times 6x squared minus 5. So that's our answer. And then we have to set 6x squared plus 5 not equal to 0. And here we actually get a negative number. So 6x squared, or this would be x squared, is equal to negative 5 over 6. We'll never square a number and have it be negative, so we don't have to worry about this, because it's never going to be a real number. So we have no domain here. So no restriction on the domain, so that's it.